Looks like we're live. All right, everyone, FusedVR coming at you today, and welcome back to our third live stream. Super excited to be here with you guys, and if you're new, welcome to the stream. Today we're going to be going over some VR UI and VR UX, and it's just kind of a continuation of what we've been working on the past two streams, which is about building a basic cardboard app. I'll show that in just a few minutes. Um, some of the art assets are created by my friend Abdu. He'll be in the chat with you guys. Yep, he just said hello. And yeah, I'll be monitoring the chat, and he will as well. And feel free to ask anything about anything we're doing. This stream, I'm kind of trying to keep it sort of basic. Very little coding. I'm gonna try. Yeah, there's like one part I'm thinking if we get to it that'll involve a little coding, but should be pretty basic. The most of it will just be within the Unity editor, and just kind of exploring concepts and ideas about UI that don't necessarily really carry over from traditional gameplay. So with that out of the way, I'm going to go ahead and switch to, there we go. Cool. So I'm going to switch here, and I posted this in the chat, but whenever you get a chance, if you haven't seen this before, this is a video by Mike Alger. I'm not going to play it here because it's kind of long, but he goes over a lot of concepts about VR UI, VR UX, and really lays the foundation of like what works well in this medium, especially like things that don't carry over. And if you really want to experience that for yourself as well, there are a couple of apps out there. I know Oculus has put out like for the Gear VR, I think there's an app about VR design, and Google has also put out an app called the Google Design Lab, and that just kind of walks you through like 10 basic steps on like what are the do's and don'ts about VR design. And so we're gonna take some of those ideas and like pull them over into how do you actually go about implementing them in your own projects. So we're gonna do that here with our game Lofy Noms. Um, and I also had the chance to actually meet Mike on Thursday, Thursday this week, and it was really awesome. He was going over some of the stuff that you see in that video, um, but what was really cool is I learned a lot more about the Cardboard SDK that I didn't know existed. So particularly with spatial audio, I was kind of blown away by that, and we're going to play around with that today as well. So that's something to look forward to. Just a quick, I'm not going to play this video, played it a couple of times, but this is just kind of the reference video that we've been building upon. And I'm just going to go ahead and open Unity and show you guys what we have so far. So this is Lofy, and I've hooked it up currently to the my DK2, so you can see that here. And so when I turn the DK2, the elephant mirrors what I'm doing, and the trunk is just controlled by physics, using some hinge joints that we covered in the first live stream. And yeah, the goal here really is just move the trunk out of the way and get that food into Lofy's mouth so that he can nom on it. Nom 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 nom. And we've just got a bunch of food spawning everywhere. So that's how it looks with the DK2, and I can also show it to you guys with cardboard. If I can log into my phone. Any day now. There we go. Come on, buddy. And of course, the phone decides to lag a little bit now. There we go. So got my cardboard here. Pop it open. Let me pull up in the chat just to make sure. Oops, there we go. So there we go. We have a tap. We implemented a tap the first time to just go ahead and reset. So we can do that. And now I have it in cardboard. It's on my Note 5 phone that I use with my Gear VR as well. And yeah, works just the same. So this is what we have so far. It's really very basic. Took us what, a matter of just two work sessions to actually get to here, which is really cool. I should also mention, if you have, I think I mentioned this before, but if you have any questions, I guess as far as art is concerned, like how Abdo created these models or any of the art assets that we're going to be working with today, go ahead and just put those questions in the chat, and we'll be happy to answer those. And you can also, these models are also available. There's a link in the description. So that's what we have so far. So what are the things we want to add? So here's where we're going to get into some implementation. And the basic things we first want is like a start screen. So obviously we don't want the user to jump right away into this experience. They're not going to know what to do. And so we're going to be talking about putting where you should actually go ahead and put text and images and stuff like that in your scene. Oh, and before we get into that, so I found this on Reddit the other day, and I thought it was a really good, let me see if I can find it, really good tool. So if you do have a DK2 or a CV1, this is a link, I think it's still on the Reddit homepage, the Oculus Reddit homepage. And it basically walks you through how you would hook up your Rift to work within Unity, so you can do quick testing, which we have done before in the previous live streams. So you can go ahead. It's just going to walk you through like the basics of like getting set up and like some of this stuff. So really good asset for you guys to look at if you're curious on like how to do that with your Rift for some fast testing with Unity. Just wanted to mention that before I forgot. And so here we have our basic scene. What I'm gonna do is actually go ahead and go to File, New Scene. I'm gonna save this. And so we get a blank scene. If this is your first time with Unity, this is the first thing that's gonna pop up for you. The layout might look a little different. Usually I think it looks something more like this with the scene view open. But I prefer generally to drag that game tab off to the side so that you can see the scene view and the game view at the same time, which for me is just a better workflow. The nice thing about Unity is it's really customizable like that. And so let's just kind of hop right into like what you need to do to put like some basic text in the world. So I'm going to go ahead and go to Game Object, UI, and Text. So first thing that happens is as soon as you do that, if you've never added any UI to your scene before, what it's going to do is create this canvas object, the actual text object, and something called the event system. So let's just kind of walk through what exactly each one of these is. So this is the canvas object, and this is basically where you're going to nest all of your UI. So Unity has like a parenting system, and what that means is you'll have like a top object, and you can list a bunch of other objects below it, and those take some of the attributes from your top object onto those lower objects. So for example, actually I can't show that here just yet. We'll get to that in a second. Just to show you guys. This is the text object, and what that is literally just text. So you can see here on the right in the inspector. So this is where you see a bunch of the attributes of specific objects in your world. So this object is a text object, and you can set fonts, the styling, alignment, all of that good stuff can all be set here. And then the last thing is the event system. So we're going to be playing around with this particularly with cardboard in order to make it really easy for us to go ahead and do a bunch of interactions. But this is what basically allows you to add interaction to your UI. So for example, if you have a button, this event system basically takes input from the user and converts that into clicks or interactions with that. So we're going to be touching this in a little bit when we go ahead and implement our first button, and how we go about changing this so that it works with cardboard. So I'm going to go back to the canvas, and so let's go over some of these components. That's what they're called. So you have the canvas, you have the canvas scalar, and then you have the raycaster. These bottom two, they're important for like how things render. The graphic raycaster isn't too important. It basically tells you like if you want to the canvas to respond to certain things, you can go ahead and do that. But I wouldn't worry about these two too much. The main thing you really want to focus on here is the canvas. And so you've got a couple of options here. You've got render mode, you've got pixel perfect, sort order, and target display. Target display is important if you're looking to do mainly I think Rift or Vive demos where you have one view mirroring to your headset and then another one to like an external display. A good example is Ruckus Ridge, if you've seen that, or I guess not really Keep Talking Ridge. So mainly Ruckus Ridge. Highly recommend looking at it. It's a good asynchronous gameplay. And basically they have two displays and you can target specifically which one you want to be working with. So that's kind of what that does. But the main thing you want to really be looking at is this render mode. And so we got three options. So we have screen space overlay, screen space camera, and world space. For anything VR related, you're usually going to want to use the world space. And so what the key difference here really is, so screen space, so the screen space is basically if you're coming from like a traditional game design background, generally you'll have like a 3D world and then you'll have your 2D, the screen basically, and you can drag and drop different elements to be like let's anchor some text for showing the heart, like your health, to like the top left and maybe the score to the top right, etc., etc. And the screen space really allows you to do that really easily. But if you want to add stuff, particularly text or images or whatever you have to the world, you're going to have to use world space. So I'm going to go ahead and do that. And so now that we have that, that allows us to, this rect transform, I don't know if you noticed it before. So previously you couldn't edit it, and now you can. And that's because it's actually in this 3D world. So I'm gonna go ahead and move our text to 0, 0, 0. And this is what I wanted to mention before. Let's see. Let me go ahead and center this actually, just so that you guys can see it. So if I move this canvas, it also moves our text object. I can also move the text object, and that doesn't move the canvas. But and you can probably see that the best with this frame in the scene view. And so yeah, so you can move the canvas and it moves everything along with it. So for example, if I threw, you probably don't want to throw a cube under your canvas object, but if you did for whatever reason, where is the cube actually? Oh yeah, there it is, super tiny. But if you did for whatever reason, I can move the cube independently if I drag it, or I can move everything all together if I drag it. And yeah, I don't know if you could see that well. Let me just kind of zoom in. There's like there's the little cube right there. So yeah, it's like nested and moving together with everything. And so primarily transform movement will be applied to your child objects. Can't think of anything else that usually gets applied. You might do nesting, for example, if you're getting into a little scripting, and you there's a method called like get component in children, so that could sometimes be useful if you like want to use the hierarchy to your advantage in scripting. But generally, if you're doing parenting like this, it's best like it's usually you'll use it with the transform. So now that we have text in our world, we have our camera. So this camera is basically what allows us to see everything. Of course, if you're using the main camera, it'll be connected, and you have a Rift connected and have done those setup procedures that they've asked in that tutorial. Then you can go ahead and it'll be connected like here. For example, if I run this right now, and since my Rift is connected, that main camera is basically controlled by this DK2. I don't know if I should honestly be checking to make sure the Rift is in view. There we go. So yeah, so the Rift now is attached to that main camera. This doesn't work for Google Cardboard, and hopefully soon that the Unity and Google team will have that fixed so that it's native supported. But for now, we can go ahead and if you don't have Cardboard, we've been playing with Cardboard in the previous live streams and have imported that already. You can find that. Okay, let me pull that up for you guys. So if you go Cardboard SDK, go to here. Don't like that they don't have the downloads on this page, but if you go onto the sidebar, you can go ahead and download that here. It'll come as a Unity package. I think the zip also just gives you the files that you can drag and drop into Unity. And there's also this demo package, which we'll be going over a lot of some of the tools they use there today. But if you want to play around with that, it's like a very basic teleporting game without any scoring. But it still looks good. Highly recommend it if you haven't played with it before. Good place to get started for sure. So we're gonna go ahead and let's see, main. Drag and drop that there. One thing you'll notice is that the Skybox has become this dark blue, and that's just because the default Cardboard main sets the Skybox to a solid color. We can set it back to our Skybox. We'll also be playing around with the Skybox later today, so that'll be fun. And so yeah, so we have our Cardboard main. It's at a different position than our previous camera, and if we want to do some quick testing, we should ideally have them in the same place. I generally prefer keeping my camera at 0, 0, although Unity decides to, they'd always decide to put it at 1, -10. I don't know really why they chose that. It's kind of weird in my opinion, but whatever floats their boat, I guess. So we can go ahead and turn that camera off, and now we have the Cardboard camera in here. I'm gonna just hit play, and you can see, I'm just gonna make the game view a little bigger for you guys. You can see the game view here. We can, if we press Alt and then left click, we can simulate moving that camera. And if we press Control and actually it's without clicking here, although I think you can. It doesn't matter. Yeah. Yeah, if you hit Control, that's like tilting it. So kind of like that movement versus Alt, which is more of, I guess, this movement. So yeah, so now we have the Cardboard in there. Pull up the chat again. Cool. And now we have that. We can, let's see. So this text here. Okay, before I forget. So actually, you can see it a little bit in the game view. It becomes really obvious in VR if you look at it, and it's even obvious in the scene view. But if we like zoom in pretty close to this thing, you can tell it's super pixelated. And I really wish Unity would fix this, but I mean, I think it's a setting that comes from using screen space. But the problem is actually that the text here is just the font size is too small for the scale that you're looking at. So the way that I've found to fix this, and from some other tutorials I've seen, like it seems like unfortunately the only way to fix this is you go to your font size, bump this up to I like 96. You can play around with the number. So bump it up to 96. What happens, it'll disappear, and you need to make the height like proportionally large. So now it becomes ginormous. But now you can see that the resolution on the text is actually decent, and it's not pixelated. And then the worst part is you now have to shrink it back down by the factor that you scaled it up. So we increased it by a factor of 10. and so now we're going to have to decrease it to 0.1. Sucks, I know. Hopefully they fix that in the future and figure out a way to like actually make that clean. But for now, if you want crisp text in your virtual world, you're gonna have to do that step. And so here we go. So I as you can see, I kind of like arbitrarily placed the text in this world, but if you want to know, like as far as like UI design is concerned for VR, this is text placement is actually a huge deal for virtual reality, and I go over it a little bit in my video on the deep dive. Also, let me know in the chat if you want to see more deep dives. This is just kind of a test that we did last week. Basically, the deep dive is just going to be a video we're going to do weekly, just like these live streams. Going over, picking like a demo. We're actually going to go over sisters today in the stream, probably in like about 40 or so minutes, and just kind of picking apart some of the design choices and optimizations that other developers have made, and kind of learning from them as we go. But as far as that's concerned, yeah, I'd go over it a little bit in this video. So yeah, let me know anywhere really if you find those useful. Just good feedback for me. Anyway, so we have this text. We're gonna actually bring it to, where's the text here? Sorry, where's the camera? So we put that at 001. We want the text generally around, you want it around actually like 2 to 3 meters. So the reason for that is something called divergence accommodation conflict. So in VR in general, it doesn't simulate the real world as much as like we want it to. It's actually a problem. So in the real world, say when I'm looking at this camera that's right in front of me right now, my eyes will verge towards it, so they're actually like looking at the camera, and then my lenses will then focus and change shape in order to bring it into focus. And in the real world, those two processes focus on the same object. The problem with VR is what happens is because we're simulating depth, we are going to verge to this either super far out object or somewhat close object, depending on whatever that object is in virtual space. But then we have to focus on that screen that is literally like around here. And so that presents a huge problem, and it causes like these issues like eye strain and like eye fatigue, that like they don't really cause motion sickness, but like if you're like playing VR for a long time, you might notice that your eyes are becoming really tired, and that's because you're verging all over the place, but you're having to accommodate, and that just strains your eyes a lot. It's something I guess humans aren't used to yet. So one way obviously is because we know approximately where that accommodation plane is, the plane where we're actually focusing our eyes, you can, if you put objects in that space, then we're effectively avoiding that vergence accommodation problem. It's because now I'm verging to the same place and accommodating to the same place. So for that one specific instance, we were basically saying that, oh, it's kind of simulating the real world. So with that explanation out of the way, hopefully that was useful. What does that tell us? That tells us that when we're designing VR, specifically if we want the user's attention and like not in like a long place for a decent amount of time, we're going to want to put our primary objects in that space. So, and that's really important with text, and that's why I'm bringing up this whole issue with UI design, is because of that that problem, we're going to want to put text in that accommodation plane, which for the Oculus and Cardboard, I mean, it really depends on your headset. So like, obviously there's no best place, but in general, that accommodation plane falls somewhere between 2 to 4 meters in virtual space. So we're in Unity, it's actually really simple because every unit equals 1 meter. So if we make sure that our position here is, I don't know, say 3 meters, um, and so 3 meters specifically away from the camera. So our camera is located at 0, 0, 0. We're going to want to put our text at, we're going to say 3. Again, it depends, like the most optimal place is depends on the headset. And hopefully, I don't know if there's really any document. I think Oculus has documentation for where they want you to place it with the gear, but I mean, Cardboard, there's so many headsets that like you can't actually, they vary from headset to headset. But yeah, like I said, 2 to 4 is generally good, so we're gonna put it somewhere in the middle, like at 3. And obviously that means that our text is ginormous, which we do not want. So we're going to have to shrink it again, and probably by another factor of 10. So I'm just being consistent here and dropping it from 0, 0, 0, 1 to 0, 1, 0, 1. That Z value actually doesn't do anything, so you don't have to worry about it. I just kind of do it for consistency. And it still looks a little big, so we're gonna bring it down to like 0, 5. These are like the numbers I usually use. And yeah, I know this sucks that we're using such small numbers, but gotta do what we gotta do until it's resolved. So yeah, so we can actually, like, for example, if we want a title here, we can do that. So now we have text in our world. Awesome. And luckily for us, Abdo has created this nice title image that we're going to use instead. So let's go ahead and add that to our scene. So instead of the text, I started with text obviously because I think that's a huge, has a lot of different complexities with it as far as the development is concerned. But the images have less. I mean, still the same Divergence accommodation conflict issues still apply, but text is just, if you want something quick and dirty to get you started, it's one of the easier things to talk about. So let's see, where's the title? There we go. I'm going to, so you know, we have a bunch of assets that we're going to try and be using throughout this stream today. I'm gonna pull that off to the side. And okay, so I know I have a folder. So I'm gonna go ahead and actually create a folder. Call it textures. Yeah, let's go ahead and call it textures. That might not. Yeah, maybe images. Images is probably a better name. Just delete it. It's faster for me. Images. I guess I should also mention this because I only recently found this out. But I'm not gonna do it here because it does cause me problems. If you want to rename stuff in Unity, if you're on Windows, it's F2. If you're on Mac, it's the return key. Why that chose F2, I'm not really sure. The reason I don't want to do this is because if I accidentally press function F2, that turns it into airplane mode, and that's going to kill the stream. So I'm going to be very reluctant to press F2 unless I absolutely need to. Let's see. So here we go. Added images. So we're going to go and drag the title into here. That takes a little bit. And so if we click on title, so you can see a nice preview of it down here. And so right now it's a text share. And one thing, if you're playing around with this, it doesn't default to this, but like you want to, if you have transparency, you're going to want to select that here. I'm just going to apply that right away. Takes a few seconds. And now instead of that black, you now get the matte behind it, and that's basically telling you, it's like, oh, I now understand that all of this is transparent. Awesome. So the other thing we're going to want to do is, so textures usually apply to 3D models, sometimes to other things, but when we're talking about UI, we're going to use something called a sprite. And you can see that here it's like 2D and UI. Perfect. And honestly, if you're coming from a like drawing background or a painting background or anything like that, somewhere where you do 2D art a lot, um, I'm trying to get some more find some more artists around Stanford who are interested in that. Because one of the things that I really want to see more in VR is this adding like 2D art into like a VR context. And now you might be asking like, why would you do that? And I think the reason is one, like if you have that background, like it's actually really easy to do using these sprites. Two, like it's still surprisingly compelling in my opinion. Um, when I went to the VR mixer at GDC, ran into one of these pieces that was literally, I mean, they had like a 3D world and 3D environment, but they just put like characters as sprites all over the place, and like obviously it looked kind of like Paper Mario, but I don't know, it seemed still really well done. Everything was animated properly, and like even though I didn't get the depth perception on those characters, they still felt somewhat real. There was a sense of presence to that. So, um, and for some people, creating 2D art is easier. So if you have that background, yeah, uh, be try playing around with that. I think that'd be really cool. Um, yeah, um, yeah. F2 to rename was so silly. Um, yeah, cool. So yeah, sprites there. Did I hear? Yeah, cool. So now we have Lofy Noms as a sprite. So if we want to add that, did I not apply? Okay, I'm gonna apply it. So yeah, make sure to hit apply. When you do these types of things, it basically just changes some of the properties on the file itself. So that is that is valuable. Um, let's go ahead. So how are we going to do that? So we're going to go UI image. God, so big. So that's an image for you guys. And so what that does is it created us another game object. And here's the component on that game object for the image. There's this sprite, and this is why we had to change it to a sprite in the first place. And we're gonna just do the good old drag and drop. Now, because it was a square, this is gonna look a little wonky, so we're gonna have to play around with the scale a little bit. Or rather, let's first play around with our width and height. So obviously, I don't know what were the dimensions on this thing. 247 by 654. So we can actually just type that in. 247 by 654. And yes, that is huge. But we can scale that down a lot. So there's that. 05, 05, 05. Still huge. Let's drop that down. God, still that huge? It's actually, yeah. Let's bring it down to 0.1. Yep, there we go. That looks reasonable. Yeah, that looks reasonable. So, yep. So now we have Lofy Noms with nice colors, nice ears. I really like those ears. Good job, Abdo. And yeah, so we're gonna get rid of our text because we don't need that anymore. And so yeah, so now we have nice image, text in our 3D world. If we want, we can go ahead and look at it. Oh, right, sorry. Forgot that we're gonna want to put our main camera back in. Delete that. And wait, did I not enable VR? What happened there? It's like tracking. is this black though? The tracking data is going through, but not the actual image. That's strange. So it was working just a second ago. Not that it's a huge deal for now. Let me just double check our build settings. No, VR support is on. Might be just one of these wires that's a little loose. Anyway, we're not too concerned about that. As long as the tracking is working, you guys can see what's going on. So yeah, so we have this. So next thing I want to talk about is audio. Actually, well, first I think the one thing I want to do is start adding a little bit of dynamic features to this. So I think something that could be really cool is we're going to go into scenes. And so if you want to ever duplicate anything, it's Control D. And of course to rename, F2. Lofy, let's see, start screen. So start screen, we're gonna yes, we're gonna save this. And this is Lofy test scene. Let's call it a test scene for now. So the reason I wanted to duplicate this was one, because we have it working before, and two is, so as part of UI you can always add 3D models to it. Again, if you're like generally with start screens, you do want to keep to that 2 to 4 meters, and so even with 3D models, it's fine to put it there. Especially like if you're talking about getting the most amount of depth perception out of it, because you'll generally get that between like the 5 and 15 meters range. You'll get a nice depth effect. Obviously, with this, we might want to push it a little back to get that depth effect, which isn't a problem. But so I'm gonna actually go ahead and copy both those. So it's just Control C, just like anyone who's used a computer before knows. I'm gonna go ahead and paste that in here. Where'd it go? Wait, where'd it go? Why is everything? Oh, there it is. So tiny. So that is, so where's the main camera here? So here we actually, in this previous scene, we kept everything at -10. So I'm gonna pull this back to -7, and we want to move this up to somewhere around here. I'm going to get rid of our fruit spawner, get rid of that, and keep the reset in. This grouping, I want to move down a little bit and add this. So basically, all I want to do is, like, if you've ever played Mario 64, you know at the beginning, their start screen is basically you have Mario's face, and he's just like wobbling around. You can like drag his face all over the place. It's kind of cool. And so same deal here. We're gonna have main character Lofy playing around with us. I'm gonna move him a little closer. Probably scale him down a bit. Yeah, here. I would drop him half. Yeah, half looks reasonable. Move him a little up, and let's just like take a look at this. Again, this is tied to the DK2, and I don't know why it's not turning on. But yeah, so on the start screen, you can play around with our little elephant, and that's cool. And so we have that. So sweet. So that's just adding just a 3D model basically to it. And now I just want to double check how we're doing on time. It's 10:40. Make sure I cover everything that I wanted to. I mean, unless you guys have questions, honestly, like feel free to like ask about literally anything. Like doesn't necessarily have to be about UI. These are just like office hours, really. Like I'll be going over this stuff, but if you have questions about anything in particular, just shoot them my way, and then either me or Abdo can answer them. So we've gone over text. Let's go ahead, play around with audio. I think that should probably be the next step. So what we're gonna do here is we have a few audio clips. I'm gonna just go ahead and import them into Unity. Create another folder called audio, and so these are our royalty-free music. I've got them. There's a link to them. Actually, I don't remember if there's a link or not. I put the copyright information in. I don't remember if that copyright information had the links, but you can find them on that website. I'm pretty sure the website was on there. But you can just go ahead and drag and drop them. These are, so while that's going, let me, come on. I think they're WAV files. Could be MP3 files. Boom. So they're stereo files. These are MP3 and or is this MP3? Cool. So two MP3 files. And these are just gonna be our background music. And then the other thing I want to point out is we're gonna go to the asset store for the last piece of music. And if you haven't been here before, a bunch of cool stuff. I'm gonna be looking for cartoon sound effect. Is it what it was called? Nope. Let's go here. Get rid of that. Yeah, game sound. Yeah, I believe it was this one. Yep, this looks right. So I'm gonna go ahead and import them. It'll be a download button if you haven't gotten the asset before. But this one's a free one, and I've already downloaded it before, so it's saved locally, and I can just go ahead and import it for free. And we just click the import button, just get those in, and we can go ahead and close this. So it's on making a portal system in Unity. Some portal to game. Well, yes, that too. Also for loading levels. So are you talking about like the portal system, as in like what's it called? The lab in the Vive, where you have like this photosphere, and you just kind of like pull it into your head. Load a level with a portal without the game stopping. Yeah, let me know. Yeah, unfortunately, there's like a 15-second delay or something. But let me know if you're talking about something very similar to the lab. In the Vive. Actually, let me actually go ahead and pull that up. The lab Vive. Ah, come on. Maybe images. Yeah, something like this portal here. So it's like you just grab it and then you pull it into your head. There is a loading screen, but I guess if you're talking more like walking through a portal, I have seen it actually. You do want to be careful because obviously like having two different scenes will like if you don't optimize correctly, it will cause issues as far as like lag is concerned. But if they're very simple scenes, it should honestly be fine. Just to like if you have some way of like moving between them, like whether that be room scale VR where you're walking or like a teleporting scheme. As long as you like know what those are, should be fine. But like for the lab, they specifically are like teleporting you in. Let me know if that answers your question. Let's see. So, right, audio. we have that's a cool mechanic, but not what I meant. Think about having a room where you can load a portal on a wall and load a room and just walk into it. Yeah, yeah. I'm not sure if the stream is caught up yet. But yeah, I've seen I have seen like a prototype of like you basically are like I guess in like some sort of lobby, and there are a bunch of different doors. This was built in WebVR, I believe. Like I don't think it was Janus VR. Might have been, not sure. But yeah, you can like open a door, jump into that world. Um, I think everything was like pretty. I'm trying to think if it was ever laggy at some point. There might have been a couple of times. This was a while back when I tried it out. But yeah, you could do that. Um, so yeah, just keep firing away those questions. Sorry, unfortunately there is like a stream lag, and maybe one of these days that'll be resolved. But for now, it's just kind of what we got to deal with. So yeah, so the reason I guess I imported the cartoon game sounds is because I want to. So when we're gonna be playing around with 3D effects as well as like ambient music. So for the start screen, it's gonna be ambient music, but at some point we do want to add in 3D sound effects. Well, let me grab a quick drink of water. Okay, cool. So let me make sure. Yeah, this is the sound clip I want. So that's just basically kind of like a very simple doink sound. And the reason I bring that in is like when we have like one of the fruit come and hit you on the trunk, we just want to play a simple sound effect. So we're going to be doing that. So let me go ahead and close that out. And then for as far as background music is concerned, where did I put it? I put it here. Yeah, I can't remember if I wanted this as the start screen music or not. Yeah, this is all just like royalty music, and I was like, I wanted something kind of sum up. I think this is what I wanted for the start screen. Yeah, I think so. Yeah, so I just kind of was like browsing the web and found these, and there surprisingly wasn't that many that I thought would fit. Granted, I didn't do that much searching, but I thought these came close enough. So we're gonna first look at Unity's audio, and then we're gonna go and look at Cardboard spatial audio, which I thought was a really cool. From the demo they gave when I went on Thursday, was really cool. A lot of cool effects, and they said it worked with not just Cardboard, but literally any VR application you're building. And so if you're building for, I think, Oculus or Vive, I think it's definitely something you should use. It basically it does take a bit of computation, which is why I'm hesitant to recommend it for Cardboard. Although obviously, like they're trying to optimize for it. Um, but Oculus and Vive, I think, should definitely use it. It's basically what they do is spatial audio, and they do a bunch of reverb calculations and calculations based on what things should sound like, based on like kind of the shape of your ear almost. So they're doing a lot of reflection calculations, and like if you have like a room, it'll do like audio sound bounces. It'll also if you have like a wall in between you, it'll calculate for that to soften the audio and what you hear. It'll also like do calculations for like stereo audio. Doing a lot of calculations, pretty optimized. When it was asked if there was any performance issues, they said like yeah there would be some for Cardboard, which is why I wouldn't necessarily recommend it on mobile systems, but definitely for Oculus and Vive, like those like sound is like one of those like it's first the visuals for VR, like that's really important. Like you got to get those nailed. And then the second thing that's almost equally as important is audio, because that your consumer is basically giving you up those two senses in this VR experience, and sound really sets the tone of what they should be feeling. So like if you're in horror and then you hear upbeat music, it's like it's not going to be nearly as scary. How am I doing on time? 10:50? Cool. So first thing is going to be audio source. So this is Unity's, and so this is basically whenever you create an object, it creates an audio source, and you get a bunch of different properties here. So if we want to create a 2D sound, which we're gonna do, you just drag and drop your audio clip into the editor in this audio clip section. And then just make sure you check a bunch of things. So for example, here, since this is going to be our background music, we're going to want to loop it. We're also going to want to have it play on awake. We don't really want any scripts like touching this. We can position it wherever we want, but since this is a 2D sound, it's not going to really matter. So we can change volume, pitch. Actually, let's go ahead and get it playing. So, for example, so now it's like a lot quieter. Let me know in the chat if you guys can hear this, or like you notice these differences. I'm gonna leave it at 1. We can change pitch. Yep, plays with it. We can change the stereo balance. We can also play with the 3D settings. So where is that? Yeah, Spatial Blend. So Spatial Blend here tells you if it's 2D to 3D. Cool. So Spatial Blend tells you if it's like a 2D or 3D sound. So we're gonna make this a 3D sound just to test. And so all they're really doing is based on your settings here. So you can have this as logarithmic roll-off or a linear roll-off or define your own. They're just checking what the distance between you and your audio listener is, and then adjusting pretty much the volume and maybe some of the stereo. And let's go look at the audio listener really fast. That is here. So we're in the cardboard, which I have disabled right now, but there's an audio listener here. Generally, a default attached to your camera, so you don't have to worry about that. The one thing I do want to point out, and we're gonna get into this really soon, and I haven't played around with this too much, so I'm gonna be learning as we go along, honestly. Is this cardboard audio listener. So if you want to use this with stuff outside of cardboard, you have to add a cardboard audio listener in, and you can play around with all of that, and then that'll get you the spatial audio. So that's that. We're gonna again drop. Oh, I guess I didn't show you the 3D audio. So I can like drag it super far away, and that logarithmic roll-off is gonna be affecting it. So, and I can also put it really close, and I think there will be like stereo changes if I like go out there. Oh, I just noticed. I don't know if you'll be able to hear this in the stream, but there is a Doppler effect. So if you are moving the audio, it changes the pitch, which is I've never noticed that before, but that's actually really cool. I appreciate that that's in there. Cool. So that's normal audio, and I think I mean again I haven't played around with the cardboard audio, but we're gonna do that right now. So cardboard audio source. So looks very similar. It's a custom script that they have. So again, we just drag and drop that audio clip in here. You have some of the very similar settings along with pitch, gain. It looks like there's, yeah, I don't see it. Okay, so it looks like theirs is pretty much required to be a 3D sound source. So, I mean, again, this is probably not something we would want for this one. We can just go ahead and use unities because it's just a 2D sound that we want for the background. But yeah, we're gonna be using this for that doink sound for sure. Um, so I'm gonna go ahead and but let's just play it anyways, just to kind of test it out, make sure it's working. Object reference not set to an instance. Oh, so right. So like I mentioned before, we had it disabled, so there was actually no audio listener in here. We're gonna just go ahead and add that to our main camera. So I just have to add cardboard audio listener, uses world scale. Everything looks good, so hopefully this should work. No. Oh, I also need the cardboard SDK. Interesting. Good learning process. Um, yeah, this is just something, when you're trying out something new, like, you'll get a bunch of errors in your console, and then it's just like debugging one step at a time. And still no sound. Why is there no sound? That's strange. I thought it would just be that simple, but apparently not. Uh, let's try it with their. Oh wait, where did I put the audio source? Oh, that might be why. Let me drag this closer and also turn this on. Let's make sure it works with cardboard before we. Still nothing. That's really strange. He seemed to make it look super easy when I saw it when I saw it before. Just looping. Oh wait, do I hear it? No. Huh. That is strange. It's within our. Yeah, it's within there. So from what they showed us on Thursday, that should be the area of which where the sound is playing from. And I don't remember how you changed this, but I think. Oh yeah, he changed like the alpha, so that lets you change like the localization of where the audio is. You can also change the sharpness, but that doesn't seem to be doing anything. Um, but that is really strange why it's not playing anything. Play on awake is selected. I don't know if it's like looking for anything else. Quality's high. I'm gonna play around with this later. That's really strange. It was working in the demo, and I thought just dragging and dropping everything in should do the trick, but I guess not. Alright, we'll play around. We'll try playing around with this again in a little bit and see what happens. But we know for sure the 2D audio is working, so I'm gonna go ahead and use that. Strange. Might. Yeah, that is really strange. Actually, you know what I want to do right now is just make sure that 3D audio was working in their demo scene. Because I believe I have that installed. Where is it? Cardboard. Just import the demo scene. So this is the demo scene that has a bunch of like those different tests that I was talking about earlier. And we're just gonna, we'll save this and play this. There are compiler errors. Cardboard on GUI does not exist. Well, we can just comment that out because we don't need that. And that is, maybe this is, I did not have that issue either last night when I was playing around with that. things you run into on a live stream. But I mean, that's the whole point, I guess, of doing the live stream, is like to show you guys like what really happens in development. That's so it's, I guess, good to like sometimes run into these issues. Actually, no, it's never good to run into these issues. What am I talking about? But you just gotta debug when you gotta debug. I don't hear any audio here either. That is so weird. I'm pretty sure there was. Weird. Okay. I'm gonna play around with this and maybe well, we might play around with it later, but for now we're just gonna use Unities. That is all I can say. Yeah, that's so strange. Okay, so we're on our start screen. Let's just double check that the audio here is working. Yeah, we're good. Yeah. All right. Cool. Now we have audio. We'll add it to our other scene later. But I'm gonna take a quick break now, and audio in here. I'm just gonna let's just say, yeah. Let's just go back into that. And yeah, if you guys, Android Studio Simulator. Okay. So yeah, in the chat there's something called Android Studio Simulator. Seems like that also does the job. So yeah, you guys can check that out as well. Sounds legit. I'm gonna quickly rename this as BG Music. I like having a naming convention just so that I know what everything is. Otherwise, like when you get into bigger projects, like things get a lot more messier, and like if you don't name things well, it just becomes a mess. So we're gonna just try to keep everything named consistently. So we have our background music here. We're gonna add that also to the actual game. Let me save that and add it here. So again, oh wait, sorry, not UI. We're gonna want audio source. And where's the audio I added? So this was the in-game music. BG music. We're gonna loop that, and that should be good. Just double check it. Yep. Just gotta keep that upbeat music, because this, like, for like cartoons, I generally like to have like an upbeat music. So the next thing I wanted to talk about, unless you guys have any more questions, which keep them coming. That's what I want. Oh, okay, yeah. So it looks like Android Studio Simulator is an emulator. So I'm actually using a real device here, but there are also emulators available. Yeah. So the next thing I want to talk about, and hopefully this one is quick because I do want to get into implementing a button, and that's the part that'll require a little scripting, but should be simple, and like should be totally accessible to like people just starting out. So let me go ahead and create a folder for materials. So if we're talking about skyboxing, skyboxes also really set the mood. I was reading, I forget where I read it, if it was on Facebook or on Reddit. There was some guy who wanted to take, if you have like a theta or like a 360 rig of any kind, just take a picture and use that as a skybox, which I thought was really cool. Cool concept. And unfortunately, I don't have a 360 image with me right now. Could probably find one, but that might take a while. But I just wanted to show you guys the basics of like what Skybox is and like how to manipulate it and like what Unity comes with. So if you go to window lighting, I already have it open here. But if you go to window lighting and then go into the scene tab, there's environment lighting, and that lets you change some of the stuff on the skybox. You got to make sure that the camera is set to view the skybox. Like cardboard is not set by default, but if you do, then yeah, these changes matter. And so they use a default material, which is called the default skybox, and you provide the directional light, which is whatever is built into the scene. And the neat thing about the directional light is if you look somewhere, here's the sun, and if we go ahead, gotta find my directional, oops, gotta find my directional light here. So as you can see, so the sun's rays are pointed downwards like that, and that's actually mirroring where the sun is. So here's a neat little trick. If you want to make it nighttime, oops, I messed up there, but I think you saw it. We can have it point upwards, so effectively the light is going that away from the Earth. And yeah, if it becomes a dark, you can simulate a whole bunch of settings with this default one. It's really cool. And if you and so if you want to do more than just that, we're just gonna set this back to the default. Yeah. So yeah. Did I miss one? That what? Okay. Thought I missed something in the chat. Okay. So now if we want to do a little more to the skybox, we're gonna have to create a new material. Call this skybox, and going to change the shader. So any material is associated with shader. And for Skybox, there are 3 different types. So you have 6-sided, cube map, and procedural. For the purposes of today, we're going to be using procedural, but I think if you want, like for example, if you want to use a 360 image, I actually bought a Ricoh Theta S a couple days back. It should be coming next week, which I'm super excited for, and then I might play around with this feature also, see if we can get it to work. But yeah, so you have 6-sided cube map and then procedural. We're going to be using procedural today, but I'm just going to show you guys what 6-sided would look like. You basically provide, if you're thinking of, so I guess the way a skybox works, if I'm taking a step back here, is really, it's just, imagine you have your world, it's kind of like around here, and then I'm going to basically, at a super far distance, or effective far distance, I'm going to be throwing up a box basically around me. And that box is then just what is what I look at in the scene. So that box is basically represented by these 6 images that are facing inwards, and you have one for each direction. So plus z, minus z. I don't know which one is plus x, minus x. I guess plus x, minus x. Might be. You'll have to play around with these. I don't remember the exact orientation that they want you to use. And then, oh sorry, plus z minus z, I think. Plus x minus x. Might be the other way around. And then plus y minus y. So that basically fills your box. And on Unity's, if I can pull this up really quickly for you guys, Unity Skybox. And so yeah, so this is, it's just, if you just Google that, shows you the basic steps of like building a skybox if you have those 6 images. There are, I believe, a few on the asset store that you can download and play around with. A lot of them are space-based. For some reason, a lot of people like space and robots when designing games. So you'll see a lot of that. The reason I bring that up is because when I was looking for music, a lot of it was space themed or like dungeon themed or whatever, which I guess a lot of games are. But if you want something a bit more upbeat, seems to be hard to find. I don't know why. Random complaints. So anyway, so we have a 6-sided skybox. You can do a cube map, and that's basically the same thing if you have it as like one. If you have those 6 sides in a specific order. So for example, if you have an image that's like has them all lined out, you can create a cube map in Unity and then just drag and drop that in. And then the last one, the one we're going to be using today, is the skybox, the procedural one. And so yeah, so you can play around with the sun. It's basically, honestly, it's just this, but it gives you access to a few more variables. Like for example, let's actually go ahead and drag that here. And so yeah, you can see things slightly changed. So we can make the sun huge, for example. We can make it really tiny. We can make it 0.04 and change the atmosphere thickness. Wow, I did not realize that that's what that did. But yeah, you can do that. And the things that I want to play around with a little bit, I actually didn't pick colors. So, Abdo, if you have suggestions for colors, can you like drop them in the chat? Because or anyone really. Yeah, I actually did not think about what colors I would want to use for this. I don't know, maybe we can go with the green and see if that works well. But yeah, you get like a nice, this almost feels like an aurora. I'm gonna probably drop the sun altogether. We can just choose none for the sun, and maybe an orange. No, I'm lousy at picking colors. I'm no artist, that is for sure. I feel like the stream is still catching up, but yeah, you can play around with this. Get whatever effect you want, really. Eh, kind of the green and the green. Oh, you know what I should have done? I should have just like you can. There's also like a little color selector, so I can like pick the exact. I don't know what that did. Oh yeah, I guess it did pick the exact color. Uh, so we can just like pick the exact colors of uh of the title and use those. That looks right. And yeah, although for whatever reason the sky doesn't look like green as I want to, but whatever. Get the idea of like what you can play around with. There's exposure, a bunch of different things to like change the lighting and how that works. So this is probably not the best thing. The one thing I do want to point out is like where the horizon is located. You generally, this is something I learned when we were developing our first Gear VR title. Is um, this Skybox actually has a huge effect on like some of the ways that people perceive claustrophobia. Um, so like I mean here it's like a nice color, but one of the complaints we did get when we were developing our first Gear VR game, if you want to check it out, it's called Naviland. It's on Sideload VR if you're interested in kind of looking at that. It's we never actually ended up publishing it to the Gear VR store, but the reason I bring it up is like that Skybox we used there, we got a lot of complaints that it made them feel a little claustrophobic, and so that's kind of something I want to bring up as well. Is Skybox is pretty important as far as like giving a sense of like how big an environment is or how making the user feel comfortable, and whatever trying to mood you're trying to bring out. So um, just keep that in mind. And like the Skybox is, even though it's like a small detail, it's actually a pretty important detail. So yeah, that's just kind of what I wanted to talk about with the Skybox. And so now I want to get into the fun part. Fun part is how do we connect these scenes that we've built together? And this part, this is the part we're going to start with the basics, and then there's going to be a small script that we write, and then that should hopefully tie everything together. So for that, and yeah, how are we doing on time? We're doing pretty well. So yeah, cool. Let's go ahead and, sorry, not this. I want to, for the canvas, add a UI button. And again, it's huge. So honestly, this might be the point where we copy the scale, and instead of putting it individually on each child, so this is what I was talking about at the very beginning, we can put it right on top of we can put it right on top of the canvas object. Again, we have to position everything properly, so I'm just going to do that really fast. Oops. But yeah, so now that shrinking scale is applied to everything, so we don't have to do it for literally everything. I'm gonna make this thing huge, 300, and make this text reasonably sized so you can see it right away. And so yeah, now we have a button, and I'm gonna put it about there. Maybe make the text a little bigger actually. Be 128, 148. 148 looks reasonable. So there we have that, and so yeah, we have a button. So going back to the event system that we had talked about initially. So for cardboard, and actually this is actually a good thing that I imported the demo scene earlier on. Save that. So if we, in the demo scene, they do have an event system. And that event system uses the gaze input and touch input. So these are two, I believe these are two scripts. I don't remember if touch input was used by them. I know gaze input is something they wrote specifically. I think, yeah, it looks like touch input is something generic. But they use both of these in order to tell any of the UI in your 3D world that they've been activated. And it's definitely a lot easier to use this than writing it yourself. You can do it. In the past, I've actually done it. I've written the code myself. The way you do that, just as a quick summary, is basically using something called a raycast, which basically says, let me shoot a ray or an arrow from where I'm looking straight out into the world, and if I run into anything, notify whatever my script is. Notify the script of the first thing I hit, or if I hit anything. Yeah. So, but the cardboard team has done that nicely for us. So we just have to put these on our advanced system and make sure the standalone is not there. I'm gonna go into the start screen, and where is the event system? There. We're just gonna get rid of this, and I'm going to add gaze input module. Cool. And touch input module. Boom. Done. Replicated that. And so we have the event system set up. And so now what we're going to do is write our first very basic script for this live stream. But wrote a bunch of scripts last time. And something I do want to ask you guys is, so last time was a bit more code intensive. This time kind of targeting more towards new people entering VR and kind of the UI stuff of that. So let me know which you would prefer, like more coding or more kind of basic stuff. And yeah, we can kind of tailor these to match that. Yeah. So I'm gonna go to our scripts folder and then write. This is going to be more coding. All right, 1 vote for coding. Where is it? Where's that button? So, okay, cool. So I'm gonna make this. This is basically gonna be the play button. Stop it. Okay, cool. And for that button, we're going to have scene scene transition. And so literally, this is just gonna be a very short script. Gonna open. Let's just open. Let's drag this over here. You can see. And yeah, now that I have this open, literally when I imported cardboard, this cardboard on GUI wasn't available, so I just commented out all of those lines. I don't know why it went missing or like what it's supposed to replace, but just so you guys know. And instead of update, actually we don't even need to start. We're just gonna get rid of those two. So we just have a basic class. And we're just gonna create public void start game. And so in Unity 5, that you used to not need to do this, but you add this line here using scene management, so that enables you to do. Your designers need to comfortable with coding. Yeah, just read the chat. So VR designers need to be more comfortable with coding. To some extent, I agree. The thing with VR is a lot of the stuff you'll see right now, especially like the 360 stuff. There's really no coding involved, and my personal take on it, I think a lot of people may agree, is so obviously if you're building games, you need coding. Like you need someone who knows Unity or Unreal or anything like that to be able to design and add those interactive elements. But ideally, and this is actually something me and Abdel are working on, is you shouldn't, if you're just creating a story that's not interactive at all, you should be able to like hop into say Unity or Unreal or whatever it may be, and without touching any coding, not even blue script, like honestly, like just be able to create a very simple story or a world that just kind of like revolves around you. And for a lot of people, that's actually pretty powerful in and of itself. Like you'll see a lot of videos of people reacting to being on the moon, for example, and looking down at the Earth. Especially like I've seen a few videos just people like break down in tears, which I guess you can't really see with the headset, but I guess you start seeing these streams of tears coming down their eyes like from underneath the headset. Yeah, you can look those up. They're like videos of those. But yeah, it's really powerful, and like ideally, if we want a lot of VR content creation out there, people should. I think people shouldn't even have to code for that. But I mean, if you guys want to see more coding, I'm happy to do that because that's my background. So yeah, that's just my 2 cents on that. Yeah. Anyways, so going back to this, so we're gonna go to scene manager dot load scene, and so you saw that so this thing takes a parameter, sorry, not 0. That is your scene build index. Now, what is that? So scene build index is if you go to build settings. So whenever you make any app, you'll have, if you go to file build settings, you'll have scenes in build. So what are scenes in build? Scenes in build is literally when you make a build of your game, whether that be Android or PC, what are the scenes that it should load into your game? So for example, here we want the start screen and then the Lofy game to be the scenes that we have in our build. We don't really want this test scene. I'll actually probably delete it soon because we already copied it into the start screen game. But to the right of that, you see these numbers, and these numbers represent that build index. So for example, if we go back to our script, I wrote 1, and 1 is exactly what it is. It's the game. So now we'll just play around with that right now. So I'm gonna go back in here. Everything looks set up. Oh wait, sorry. We're going to first go to that button, and we're gonna what did I call it? I called it scene transition. I'm gonna attach that script to this button. You can actually attach it anywhere. I'm just for ease of use, I'm attaching it to the button, but you don't have to if you have like your methods in some other class. And we go to this onClick function, hit plus, and that adds a function that we want to call. So it requires, and this is the reason I was saying that the script doesn't have to be attached to this, is because you can drag any game object here as long as it has the script you want. Drag it there, and then if you click here, this is the function it wants to run. So you can run a game object function, or it basically looks through all of the components and gives you those options of like what functions that you can call. So I'm going to go to scene transition, and if I did it right, it doesn't show up. Sometimes it just takes a while. That's what I noticed. I don't know why it takes so long. Sometimes it just has to compile in order for it to find it. Yeah, there it is. So now we can just call start game. So now that's hooked up, and assuming I didn't miss any steps, we can drag to look at it. Yep. Yep. And so yeah, that just switches the scene. The lighting is a little off. Let me double check the lighting issues. So one thing I have noticed a little bit is the lighting does, for whatever reason, when you switch scenes, the lighting does, yeah, okay. It's if you don't, so here's the problem, and I think this is a bug in Unity more than anything else. If you have it on auto, I think it usually is fine, like when you make a build, and we can try that out. But if you have it in auto, it sometimes doesn't bake the lighting into the scene right away. So you sometimes have to remove that auto function from the lighting tab. We can try building it and see that fixes the issues. That takes a little bit of time, depending on how complex your scene is. But although it shouldn't be taking this long. Oh, there we go. So that just creates the light maps, and we can do the same thing here. Just have that run real fast, hopefully fast enough. Yeah, sometimes. Yeah, the more complex your scene is, the longer this takes. It's just doing a bunch of calculations with shadows and everything like that. So this looks fine. Oh no. Gotta make sure I'm in line with that button. Should not. Oh, I keep recentering. There we go. Yeah, now it looks fine. And so this is using the DK2, but we can change that again in this scene. So let's save. Turn that on. Go to intercept vector. Turn this off. And something I did everything right. Oh, I guess I also need to. This is something we did last time. Oh wait, is that right? Oh, sorry. This guy. Just attach that here. So in the first video, I kind of explained this process, but I just got to make sure the cardboard camera is attached as opposed to the VR camera. And we can, just for consistency, use the same Skybox. If I can remember where I put it. Yeah, here. Yep. So that's that. That is creating a very basic button and going back and forth between the two. And the one thing, yeah, we have time for this. So cool. I think this might be the last thing I go over, unless other people have more specific questions. But the last thing I want to go over is, and this is actually really important for VR UI design in general, is doing these transitions. We mentioned it briefly before, but like, how do you actually go about implementing a transition? So like the most commonly used, so we talked about portals a little bit, but most commonly used one is a screen fade. And by that, what I mean is fading out to black and fading back in once you have the scene ready. So for that, actually, here, I'm going to pull that up here, is so if you haven't looked at, there's this YouTube channel called Everyday VR, and it's right there. He has a blog where he actually has developed this fade in, fade out package for Unity 5. You can find it here if you just Google Everyday VR Screen Fader. It's actually a really good package. We're going to play with it right now. I have it downloaded already somewhere here. So I'm going to go ahead and do that. I'm just take the screen fader, import that in. And yeah, this is free to use, completely free. He wants people to use it. Awesome dude. And so yeah, that's now we have the screen fader. I'm gonna go to where's that scene? Scene. Start screen. Cool. And I'm going to create a empty game object. Call it the screen fader. I like putting everything at 0, 0, 0. And yeah, this guy. So we're gonna drag and drop that in. So we're gonna be using this, but if you want me to go over how it works, I'm happy to go over that as well. Just let me know in the chat, and I'm happy to like open it up and just kind of break down what exactly is going on. But while I'm waiting for responses on that, so we're gonna try this out right now. So we have a few tabs that are, sorry, not tabs, a few options we can play around with. And here's fade in, or fade out rather. So if we unclick it, we fade out. Here's review. All right, that I will. And we can also fade it back in. We can adjust the time. So if I want it to go really fast, back in really fast. Do that. Change the color. I recommend black or white. You can play around with other colors. You might be able to get some good effects. And then the last thing is it's more for the script to use is what material. So we're gonna go ahead and review that. So let's just open up the screen fader script. And so yes, this screen fader. These are the variables that he's defined as being public. So you have the material, color, fade in, fade time, and fade in. So he gave them default values, but yeah, again, we can change those in the inspector. He has a few private variables here to keep track of what state he's in. And here are the main methods. You have the fade out, and you have the fade in. And then here's the primary method that does the fade. So everything, so let's start where everything actually begins. So in update, so update is called every frame that a script is being run. So what he's doing is he checks to make sure that he has the state of what was happened last and what is currently happening. And that currently happening is what's happening in the inspector. So he's checking to make sure they're not different. If they are different, then we're gonna change our state to make sure that we're in the proper state, and then we're gonna start doing the fade. So that calls this coroutine. So I believe I briefly mentioned this last stream, but just to quickly recap it. Coroutine is basically, if you think of it like a thread almost, except it's not. You basically put in control statements to control when you want certain events, or how much code you want before you give back control to the main thread. So here what he does is he looks for these screen fade control objects, and we'll get back to that in a second. But he wants to make sure that he's deleted all of them from the previous fade. And that's what he's doing there, just doing a little bit of cleanup. And then, does Unity parse any languages that aren't garbage? EJ, I guess what do you mean by that? Do you mean C# is garbage, or do you mean well, I guess to answer your question, so Unity does what was it called? I think it's Boo. Was it called Boo? Or is it Unity script now? I can't remember the naming. I actually do like C Sharp. I'm not gonna lie. There are little quirks. I guess it's primarily because I came from a Java background, and C Sharp and Java are pretty similar. God, there's this fly in this room. Um, but I don't know. I like C Sharp. Yeah, it does support JavaScript. And it used to support a language called Boo, but I don't see that here anymore. Let me just quickly Google Google that for you. Actually, though, if you're interested in like real-time coding, there is a package, I believe, for Python that allows you to do mods. And then you could and I'm assuming like if it's allowing you to do mods, you would also be able to use it as an editor script as well. So if that's something you're interested in looking into, you can do that. Supported scripts. That's like my language low level. Oh, you like C? Actually, well, so glad you mentioned that. So this is actually dependent on what you're programming for, but if you like low level like C, C++, um, man, these bugs are just flying over. I guess because I left the window open. Oh well. Yeah. Here's the official, I guess. Why didn't they put JavaScript in here? Um, but you can develop using. So if you're developing for Windows, you can use DLLs, and obviously you can write those in C, C++. If you're developing for Android and you want some custom functions written in Java, you can add create a jar file with those Java files and put them in. Same with Objective C for iOS. Um, I believe Mac has something as well, but I've never used it. Anything else? I think, oh yeah, yeah, I guess Android also you can develop in C as well. So there are options. Um, I the those of course those have limitations in the sense that um, whatever you write isn't going to be cross-platform. So the reason you really do want to write most like people get frustrated if you don't write it in C Sharp or JavaScript or any of the native supported languages because you lose that ability to write to Android. So if you're talking about cross-platform development, you lose the ability to write to Android and iOS. So if I write any custom Android code, I have to write that same code in iOS, which kind of sucks. Unity script. Okay. I guess yeah, it's just a name. Oh yeah, yeah, it does say that. I completely didn't read that. Um, yeah, okay. Unity, yeah, there you go. There you have it. C Sharp, Unity script, and Boo. For whatever reason, you can't create a Unity script in here. I don't know why. I thought you used to be able to, but that might have changed just because, as you saw in the statistics, very few people use it. Uh, and yeah, I don't use it also. Um, Yeah. So I guess going back to this. So what D from Everyday VR does is then he looks at all of the possible cameras that are um in your scene, and he uses the add component method to add a screen fade controller to it, which is a custom script he actually wrote, and you can see that here. All it's really doing is doing some OpenGL calls. So yes, this is the low-level version for C Sharp. If you're interested in doing low-level stuff. Um, but yeah, all he does is he gets the material property on your Android device. Uh, well, this works Android and iOS, but and then just starts running some OpenGL calls to like fade it to black basically. It's basically creating an OpenGL rectangle, I guess, over the whole screen and then just changing the alpha value of it. Um, so he just adds that to all of the cameras, and that's actually what he was deleting before. And then he just calls another coroutine to like fade in or fade it out. And so those do exactly what it says. It does the quick check to make sure you're supposed to actually fade out. So we're just going to go over fade out real fast. Has a variable for time, color, and the color of the current material. And then he just does a quick loop where he uses wait for end of frame. So like every frame, he runs these calculations until this loop ends based on this condition here. Elapsed time is the fade time, less than the fade time. So that's basically counting down. And he does some math here to check how much time has elapsed. He changes the alpha based on the elapsed time over the fade time, and assigns that color. So that's just happening in the loop. Same thing's happening in fade in, except he's doing the inverse. So like he's have this 1.0 f minus the clamp value. And then yeah, the last thing here is just making sure all of those faders are off when you do a fade in. And yeah, that's basically what's happening in this script. So it takes some time to understand it. It took me some time for sure, just to like walk myself through exactly what was going on. But nothing terribly complicated. If you're coming from a programming background. Yeah, so that's that. Let me know if you have any questions specifically about, I guess, what he's doing in the screen fader. Have to take those as well. Okay, cool. So now I'm gonna use it. And so the first thing we're gonna do is actually go into where's our scene transition here? So we're going to create a reference to our the screen fader that we put in the scene. And so when we start this game, we're going to actually want to call a what was the method we're supposed to call, or what the variable we're supposed to change? I think it's fade in. We want to set to false. So fade in equals false. Done. And so now when we go ahead and click that button, it should fade out. So let's try that. There we go. Oh wait, sorry. I just realized the boo-boo I made. And so what we want to actually have happen is, or actually I'll show you what will happen first, and then you can see. So I'm gonna put this somewhere in the middle. There we go. Oh, first thing you gotta do is make sure that you set that variable properly. So yeah, I didn't assign the screen fader, so I had a null reference. That caused problems. So we're gonna do that. So what you notice is it actually didn't do the screen fade, and the reason for that is these two lines of code are running simultaneously. And so what we actually want to do is wait for we're going to want to wait for the screen fade to happen, and then we're going to load the scene. So what we're going to do is actually just like he did in the screen fader script, start transition. We're going to write a quick little coroutine so that we have a bit more control over time. So we're going to copy those lines of code in here, set it to false, and then what we're going to do is, sorry, not start coroutine, yield, return, new, wait for seconds. We're going to wait for, how many seconds? We're going to wait for screen fader dot, what is it called, fade time? Yeah, fade time. So we're going to call fade in to happen, wait for those seconds, and then load the scene. So let's try that out. Start coroutine, start transition. So we just got to make sure that when our button's pressed, we call this coroutine to happen. And go. So now we got the fade and transitions. So now the thing that you're you're gonna see is that it doesn't fade back in. So to fix that, so actually, let me do that again so that you guys can see this better. So when you call load scene, what happens is it deletes everything in the previous scene and then adds all of the stuff in the new scene into the view. So what actually happened there is, one, we got a new camera from the cardboard main camera, and then two, the other thing that happened was we actually lost our screen fader, so that actually is not here anymore. So to fix that, what we're gonna have to do is use something called destroy. It's a trick, not really a trick. It's something that you need to do to whenever you do transitions. If you want to maintain some stuff from the original scene to the new scene, you're gonna want to do something called don't destroy on load. It takes a while to actually find this. I wish it was built in with some of the scene documentation. But this dot, actually it's called this dot don't just don't, where is it? Oh, let me find it actually in the documentation. Don't destroy on load Unity. So yeah, this is the method we're going to want to use. And I don't know why the autocorrect isn't. No. Oh, there it is. I don't know why that wasn't happening before. This dot game object. So this is just a small script. So when we start it, actually, honestly, we should do this in awake. So awake is called before start, and we're just gonna add an empty game object called persistent, and drag that in. And so now underneath persistent, we're gonna want to drag our screen fader, the cardboard main, more reset manager. I think that's it. Yeah, everything else should stay the same. So anything nested under persistent is going to come with us from the start screen to our game scene. We're gonna have to do that, and let's just test that out to make sure that happens. I have compiler errors. No overload takes 2. I'm not giving it. Oh, the good old comma. So yeah, this game object. You can actually just do game object, but it's just I guess more explicit. Split and cool. So you see that persistent stuff stayed with us, which is exactly what we want. And it's some things that we're gonna have to change quick. I might be rushing a little bit because I do want to keep this around 2 hours. So we actually, since we're moving cardboard camera over, we can get rid of that, and so we can disable that, and we can get rid of the reset manager. We don't need 2 of those, and that should do it. So let's save the scene here, and the last thing I guess we want to do is fade it back in. So I'll get rid of persistent, and so we want to load the scene. I'm going to copy these 2 lines actually, and now we want to fade this back in, so we set it to true, and then we wait. So that should handle our transition, and assuming I did everything right, should be clean. Just drag that down, and there we go. Click. Yep, there we go. And then it fades back in. So that's how you'd use D's screen fader. And why don't we go ahead and get it onto device? So again, if you have questions about this process, just shoot them in the chat. I've gone over it a few times in the previous live streams, but happy to address them again. If you're having issues, we're just gonna unlock our device, and because we're using Android, it's literally just build and run. Oh, well, okay. One thing you should always double check is your player settings. We're gonna turn that off because for Android, what that actually means, even though we're using that for testing with the Rift, for Android that actually means deploying for Gear VR. So because we're doing cardboard, we want to keep that off. So yeah, let's just version 5 and save that. So I guess while we're waiting, wanted to ask you guys while you're still here, what else you guys would like to see as far as like these tutorials are concerned. Still kind of just trying to decide for next week what makes sense to go over. So I thought I'd ask now and see what you guys thought. UE4. Yeah, if you want to use lower level, yeah, UE4 is probably it'll let you do C++. But the one disadvantage I always tell people is with UE4, one, it doesn't have cardboard support. Two, the other thing you want to keep in mind is that there's a reason it doesn't have cardboard support, and it's because the cardboard, like UE4 is a bit more intensive as far as lighting is concerned and like some of the graphics. And I mean, obviously UE4 looks a lot nicer, but if you're dealing with mobile, it's not really optimized for that. So just keep them, like if you're doing PC VR development, go for it. Like that's definitely a good place to go learn. If not, I would caution that decision. But yeah, so let's look at this. So get a nice depth perception of having oh, I didn't hook that up right. Oh wait, I just realized. Let me, where's my mouse? There we go. So I actually didn't hook up the elephant here, which we can do before we leave. But okay, so hit play. So that screen fader did not work. And did I not hook this up either? It looks like I forgot to hook up a few things. Elephant's still getting fed. Okay, I did. Oh, yeah, I just realized this. So it looks like. Yeah, okay, I do remember this now. And I'm glad I ran into this because now you guys can learn. Let me turn this off. It'd be cool to see Oculus lip sync. I can look into that. I can't remember if they released the SDK on that though. I thought it was still in development, but yeah, I can look into and see if that's possible to go over. So okay, screen fader. So first thing they did. All right. Yeah, I'll look into that and see if that's a possibility for next week. Dev downloads. Got it. Sorry. So actually, for this, for the screen fader, you're actually gonna want to get rid of this line. or at least the Android part. I think it used to be the case that you needed to change the name to be on custom post render, but now I think in some update they got rid of that requirement, so now you can just use post render. So yeah, if you we'll double check to make sure that works, but if you are looking into using this plugin, just make sure you get rid of that for Android. And then the other thing is I just kind of want to hook up. Oh, right. That is a problem. So what we're gonna do actually, so we're gonna go quickly and look at our mirror rotation script. So here I actually have the camera reference, and the reason it wasn't rotating before is because it's unassigned when we do the transition, because we're pulling in, we've put Google Cardboard's camera under that persistent, so then it becomes a part of the second scene, but then there's no reference in the second scene for the script to work. So instead what we're going to do, some people might call this a hack, I don't know if it is, your camera dot equals camera dot main, or I guess rather we should do something like VR camera doesn't equal null, or if it is equal null, sorry, then we just want to set it to whatever the main camera is, and that should do it. And just let's, I guess, double check it first. That doesn't seem hooked up right. Where's that mirror? Oh, right. So this actually is hooked up, so we're gonna move that in there, and same deal with you. Here we're actually gonna set it to none, so that it actually is null. Start. Save. Now let's try it. Yep, there we go. So that looks right. And yeah, let's just go ahead and build it. We're just gonna override 5. And hopefully this should go really fast. And let's pull up screen that you guys can see. Oh, this looks like, actually, what? Oh, okay. I was gonna say I could look up the Oculus lip sync right now, but yep. So that's looking right. So we can again tap to reset. There is actually, I don't know if you guys have noticed it, but there's a bug at the moment where the event triggers, it always resets as soon as I tap on the screen. So when I'm looking at the play button, it gets a little awkward because it tries to reset me. Come on, I'm looking at you. There we go. Yep. Alright, so now we'll reset, fade it in, and no! I hit away. I'm hitting away everything. There we go. Come on. Eat them all. Eat them all. There we go. Chomp. And yeah, and then we have this nice background music. We didn't get to adding the doink sound. I might look into that for like the beginning part of the next week's stream just to see why that spatial audio stuff didn't work as expected, which was unfortunate because it looked really simple when they were showing it to us last time. I guess that was really small for you guys to see. But yeah, there we go. We've added UI to it. We've got a nice flow going in. We've got the screen faders. We played around the Skybox. Oh wait, I don't want to close this. Close this guy. Close it out. And yeah, that is UI and like implementing it in Unity for VR. If you guys have any other questions, let me know. And if you want to see more of stuff or see different stuff, let me know. And if you want to keep updated, subscribe to the channel or like our Facebook page. And we keep putting the events and advertising on Reddit as well as Facebook. So yeah, that's all to it. And I'll be on the stream for a couple more minutes. I'm just gonna wait for it to catch up, see if you guys have any questions about literally anything. And yeah. Otherwise, I'm going to close it out for today. Let's see, where is... Glad you learned a lot more, and happy to keep doing these. I think I mean, like, I've mentioned this a couple times before, but like, I mean, the reason I want to be doing these is because it allows, I think for me personally, like, whenever I want to do development, there's times where you want like someone to talk to as far as like learning something or like working on a problem. So that's why I wanted to do these in the first place, and I'm gonna keep doing them until something else goes wrong. Oh, other thing I wanted to mention while I'm still alive is if you guys are in the Bay Area and are you going to SVVR, potentially I might be at SDC. I'll be there as a volunteer, so come say hi. I want to meet you all, and I'll just be kind of running around doing a bunch of things, trying out demos. But if you see me, say hi. Love to meet you guys in person. So yeah, don't be shy. Um, but yeah, if there's anything else, I'll be monitoring the chat for a little bit, but I think I'm gonna close out the stream. So thanks guys for watching, and this has been FusedMan. I'm gonna be signing out.